Warning! While playing around with expensive components may be fun, and you might just happen to have that extra computer sitting around, do not take apart an optical drive, do not take apart a solid-state drive, and do not take apart a hard drive. These things are made in a clean room for a reason. Also, do not take a safety pin, cut the head off, and use it to short out the green and black pins on a 24-pin power supply connector to make it think it has a motherboard, just so you can turn it on. These things are very dangerous, and they can kill you. But anything for a passing grade, eh?
Hello guys, in this video we are going to introduce three kinds of drives, which are optical disk drive, magnetic hard drive, and electrical state drive.
All three of these devices are modern ways of storing data. Optical compact disc, magnetic platter hard drive, and electric NAND flash solid-state storage. While all three may be found in computers, they operate in very different manners.
First, we will talk about the optical disk drive like a DVD player and how it uses lasers to record data to a plastic compact disc.
The optical disk drive spins a disk at 16,000 rotations per minute, but can take more than 16 minutes to fill the disk with data. The red dot you can see on the disk is a laser that is used to read and write data. The laser focuses on a layer of dye in the disk. On a blank disk, the dye is translucent, but when writing to the disk, the laser burns the dye, turning it opaque. This creates a pattern of areas where the laser can either be reflected or not, depending on the corresponding data. This disk can hold over 40 billion potentially colored segments, otherwise known as bits. Here you can see the laser more clearly, and the mechanism it uses to traverse back and forth across the disk.
Now we will talk about the magnetic hard drive like many of you have in your computers.
Magnetic storage, on the other hand, is much denser. This drive has over 1 trillion bits, and it is a small one by today's standards. The magnetic drive also spins, but at a slower rate of 5,400 rotations per minute. The end of the arm in this drive is sandwiched between two permanent neodymium magnets, and contains a coil of wire. A current is sent through this coil, which produces a magnetic field. This field is carefully maintained so that the head of the arm will be at a very specific spot on the disk, called either a sector or a bit. Once at the proper location, the head will either measure the polarity of the sector and report back, or will send a current through a different coil located at the very tip of the arm to change the polarity of the sector. Here is a closer view of the magnet and the coil. As I said earlier, please do not take apart your hard drive like this. They will not survive long after being taken apart due to dust building up inside the hard drive.
Finally, we will cover electrical solid-state drives, one of the newest storage technologies out there.
Last, we have an electrical solid-state hard drive. While the smallest physical device here, it has the highest storage capacity of the three, coming in at a whopping 2,61,584,302,080 transistors. The storage on this drive is divided up among the black chips on the circuit board, with each bit a transistor in a cell. When the computer wants to write data to the device, it sends a charge to one of the transistors, which acts like a capacitor, and stores the charge. This makes the drive capable of storing data for long periods without power, unlike other flash memory. This device is capable of reading data at just over 4 billion bits per second, and writing just over 600,000 bits per second. This does come at a cost, however. Because of the wear on the transistors, this has the shortest life of all the devices, barring mechanical failure. Thank you for joining us for this exciting look at computer storage mediums. Please remember, do not mess around with dangerous computer components. I will not pay your medical bills. Thank you. Are you ready for your part? All you have to say is welcome to the show.
Why would I do that?
Come on.
Am I getting paid?
No.
I'm out of here.